This tutorial introduces vegetation analysis using ENVI Classic. We will calculate vegetation indices using the Vegetation Index Calculator, then perform some manual analysis of a few of the resultant indices. From the ENVI Classic main menu bar, select File and Open Image File. Select your image and click Open. Click the RGB color radio button. Select band 53 for red, band 29 for green, and band 19 for blue. Click Load RGB to load the image into a new display group. This data is an average scene of Jasper Ridge Ecological Reserve. A color infrared image of this hyperspectral scene is visible. We can see the preserve as a large forested area to the left of the reservoir, with a major highway and the city of Palo Alto to the right. First, we will use ENVI Classic to calculate all of the available vegetation indices of our input image. The Vegetation Index Calculator can be used to determine the vegetation indices that can be calculated for a given input file and to calculate the indices that are applicable. ENVI Classic provides 27 vegetation indices you can use to detect the presence and relative abundance of various vegetation properties. These vegetation indices are combinations of surface reflectance at two or more wavelengths designed to highlight a particular property of vegetation. Each index is grouped into a category by the main function of the index. The categories of vegetation indices are greenness, where vegetation indices are designed to measure the overall quantity, amount, and vigor of green vegetation in each pixel. Light use efficiency. Vegetation indices are designed to provide a measure of the efficiency with which vegetation is able to use incident light for photosynthesis, which is closely related to carbon uptake and vegetation growth rates. The canopy nitrogen, where vegetation index is designed to provide a measure of nitrogen concentration of remotely sensed foliage. Dry or senescent carbon, vegetation indices are designed to provide an estimate of the amount of carbon in its dry states of lignin and cellulose. Leaf pigment, vegetation indices are designed to provide a measure of stress-related pigments, including carotenoids and anthocyanins present in vegetation. These pigments are present in higher concentrations in weakened vegetation. And canopy water content, where vegetation indices are designed to provide a measure of the amount of water contained in the foliage canopy. From the ENVI Classic main menu bar, select Spectral, Vegetation Analysis, and Vegetation Index Calculator. The Vegetation Indices input file dialog appears. Select the Jasper Ridge image input file and click OK. The Vegetation Indices Parameters dialog appears, showing all of the available indices of the dataset. We can see that for this dataset, 25 of the 27 vegetation indices in ENVI Classic are available and all are selected by default. We could choose to calculate only a subset of these indices by selecting the desired indices from the list. For this exercise, we will calculate all of the available vegetation indices. Ensure that the biophysical cross-checking toggle is set to on. Biophysical cross-check is on one of the truly unique features of the vegetation analysis component in ENVI Classic. If enabled, it allows the comparison of different indices in each pixel to validate their results. If conflicting values exist between indices, for example, a greenness index shows insufficient vegetation to support the water content measurement from a canopy water index, those data values are ignored. Click the File radio button and type or choose an output file name. The output data will be stored in a new file with one band for each vegetation index calculated, and the band name will contain the name of the vegetation index ready for use in additional processing in ENVI Classic. Click OK to begin processing. The result is passed into the available bands list. You can see that each band in the new file is identified by the name of the vegetation index it represents. From the available bands list, select the Normalized Difference Vegetation Index result, then click Load Band. Explore this image. We can see that the greenest values appear high in the forested areas and lower in the urban portions of the scene. Explore some of the other greenest vegetation index results. As you examine some of the greenest indices, you can see that they all look similar overall, but each highlights different areas in different ways. Determining which vegetation index most closely describes the field conditions requires some field measurements to be taken. Explore some of the dry carbon and water content vegetation index results. These can be used for fire fuel measurements. You can see that much of the forested area in these results is masked out. These regions are masked by the biophysical cross check because there is too much green vegetation in the pixels for these vegetation indices to work correctly. Explore some of the canopy water content vegetation index results. The water band index and normalized difference water index are good water content indices, and we can see again that the NDW index has much of its area masked by the biophysical cross-check. The vegetation index results are now available for use for further processing in ENVI Classic if desired. ENVI Classic provides 3 application-specific vegetation analysis tools, each specific to one kind of vegetation property: agricultural stress, fire fuels, and forest health. These tools allow you to perform vegetation analysis by guiding you through index selections aimed at a specific outcome. These tools are available from the ENVI Classic main menu bar by selecting Spectral and Vegetation Analysis. The agricultural stress tool is designed to create a spatial map showing the distribution of crop stress. This tool is intended specifically for use on agricultural land to support precision agricultural analysis. The conditions that cause agricultural stress are the same as those that cause forest stress. However, agricultural stress analysis concentrates more on growth efficiency. Dry or dying crops do not efficiently use nitrogen and light, indicating agricultural stress, whereas crop showing health, productive vegetation indicates low stress. The agricultural stress tool uses the following vegetation index categories: greenest to indicate areas of idle cropland, weak vegetation, and healthy crops; canopy water content to show levels of water stress; canopy nitrogen to estimate relative nitrogen levels; light hues efficiency to show vegetation growth rate; leaf pigments to highlight vegetation stress. To use this tool, you select one vegetation index from each category, and ENVI Classic combines the information to produce a classification map. The classification map rates the scene from 1, representing the least crop stress, to 9, representing the most. The classes are displayed using a color ramp where purple and blue represent low stress or healthy vegetation, and yellow and red indicate high stress or the weakest crops. The fire fuel tool creates a spatial map showing the distribution of fire fuels and burn hazard for a region. Fire fuel mapping can be useful for forest planners as well as local governments attempting to mitigate fire risk within the rapidly growing forest-urban interface. High fire fuel distribution contains dry or dying plant material which contains less water, whereas low fire fuel distribution typically comprise lush green plants. Fire fuel analysis uses the following vegetation index categories: greenest to show the bulk amount of green vegetation, canopy water content to show the water content of the vegetation, and dry or senescent carbon to highlight non-photosynthetic vegetation. From the ENVI Classic main menu bar, select Spectral, Vegetation Analysis, and Fire Fuel. Because this image displays mixed terrain with both forest and urban types, we will use a mask to exclude much of the urban area from classification. Click the Open drop-down button and select New File. Select Jasper Average Urban Mask and click Open. From the Select Input File area, click to select the file we created in the Vegetation Index Calculator exercise. Click the Select Mask Band button, select the Jasper Average Urban Mask band file, and click OK. Click OK on the Vegetation Products Calculation Input File dialog. The Fire Fuel Parameters dialog appears. Increase the minimum valid greenness value to 0.2, which will mask region with NTVI less than 0.2. Accept the other default field values. Click the Memory Radio button to output the memory. Click OK to begin processing. ENVI Classic begins calculating the three selected vegetation indices, then combines them to create the classification map. The result is passed into the available bands list. From the available bands list, select the fire fuel result, then click Load Band. The classification appears to have selected most of the urban areas, including roads as highest risk and forest as lowest risk. This highlights the difficulty of using the tools in mixed terrain types, in this case mixed forest and urban. The areas of highest risk around the roads largely consist of dry grasslands. These orange areas, which can be seen in the vegetation index results as areas where timber is not present, favoring drier underbrush and clearly identified as areas of interest. There are still some medium-high risk yellow areas that are probably misclassified due to urban clutter, but these areas do not detract from the remainder of the result. We can see that much of this forest is too green to burn efficiently, but that there are still areas within it that are worthy of closer examination. The Forest Health tool can be used to create a spatial map showing the overall health and vigor of a forested region. Forest health mapping can be useful for detecting pest and blight condition in a forest and is useful in assessing areas of timber harvest. A forest exhibiting low stress condition is usually made up of healthy vegetation, whereas a forest under high stress conditions shows signs of dry or dying plant material, very dense or sparse canopy, and inefficient light use. The forest health analysis uses the following vegetation index categories: greenness to show the distribution of green vegetation, leaf pigments to show the concentration of carotenoid and anthocyanin pigments for stress levels, canopy water content to show the concentration of water, and light use efficiency to show the forest growth rate. To use this tool, you select one vegetation index from each category, and ENVI Classic combines the information to produce a classification map. The classification map rates the scene from 1, representing the least healthy forest, to the healthiest forest, which help to assess relative forest health conditions within the scene. The classes are displayed using a color ramp where purple and blue represent least healthy, and yellow and reds indicate the most healthy. Thank you for watching.